we can use these symbols for the elements in a lot of interesting ways. And what we do by using the symbols is we use a shorthand, which is understood to chemists and to scientists, to indicate what elements are in a mixture or a compound or whatever the case may be. And so I just want to show you a few of the simple rules that we use when we take these symbols of the elements and we represent compounds and so on. Let's have a look. All right, for a start, we've got elements. Let's take something right at the beginning. What would be the first one? A, B, A, C, A, D, A, E, A, F, A, G. Okay, there's the first one, Ag. And what does that stand for? It stands for argentum. And what did they used to mine in Argentina? It was silver. And so that's from the Latin name argentum for silver. And so we've got our symbol and we've got the name of the element. Now, the next thing is that we have our periodic table, as you saw, and everything's nicely arranged there. And they're all in nice, neat columns. And we've got all the elements, but they are arranged in order on the periodic table in order of atomic mass. In other words, the amount of stuff, the amount of matter in there. And we start with the lightest up here, which is H. And then we go to number 2, which is helium, the so-called inert gas. And then we go on from here, lithium through to neon, and so on and so forth. There's the periodic table. Now, when we write the name of a compound, some kind of salt like this, NaCl, what does this mean? Well, for a start, it means that it is made up of 2 different elements. You'll notice that in the symbols, when we have a 2-letter symbol, the first one is always a capital letter. The small lowercase letter just tells us which one, because we know that Na, do you remember, it's natrium, but we don't call it that, we call it sodium. So there is natrium. This one, Cl, is chlorine. Now, I haven't written down the I and E here just yet, but Cl distinguishes Cl from carbon, let's say, because there's another C, or chromium. Na is distinguished from N, nitrogen, or in A and B is niobium. NC, I think Nd is perhaps neodymium. So we've got to distinguish between these things, and we do it by using the second letter, which is a lower case. Now, this would be sodium, not sodium chlorine, but sodium chloride, and there's a particular reason for that, which we will certainly get into when we start talking about a bit more chemistry. The other thing to notice here, if you compare the symbols for this compound, sodium chloride, which you know, or you should know, is just ordinary table salt that you put on your food. They say it's not too good to eat too much of this, but you do need some of it. And we get the sodium that we need in our bodies from table salt. Now, you will also compare this with the periodic table and find that this is on the left side and that is on the right side. And this is a kind of a convention that when we write sodium chloride, sure, we call it sodium chloride, but we call it sodium chloride because we take the thing on the top left and put its name before the things we find on the bottom right. So if they're on the same line, we name them left and right, sodium chloride. Now, we have other conventions. Let's take a word like meditate. That means to sit very quietly and think and clear your brain, which some of us find easier than others. You then take a word, premeditate, you put the word pre, which is before, and that is something thinking ahead of. So a premeditated crime is not just a crime of passion that happens at the moment, it's done beforehand. So now we have prefixes, where you put something in front of a word and you indicate something. And this is the kind of prefix that we use. We have carbon and oxygen together. Now, we also have another compound of carbon and oxygen. We also have a compound with sulfur and oxygen. Now, look what I'm doing here. I'm using the symbol for carbon and oxygen, sulfur and oxygen. In this case, I don't have any number down here. In these cases, I do. Now, it is clear that what we've got here is a single carbon and a single oxygen atom. And that makes up a molecule of something called carbon monoxide. Now, that comes from the word mono, or the prefix mono, and it means one. So what have we got? We've got one oxide. When we don't have any number written down here, we can just assume that it's one, and so we call this carbon monoxide. Now, can you see what this is called? There's the carbon, and there's an oxygen, and there's another oxygen. Now, it would probably be in a straight line, but it doesn't matter. What do we call that? You got the name? Yes, it's the well-known gas carbon dioxide. And di means two. So now we have a sulfur molecule, maybe a little bit bigger than the carbon, with 1, 2, 3 oxygens. It is called sulfur. Have you got it? Trioxide. Tri meaning 3. We've also got for 4, we've got for 5, but let's just deal with those in the first instance. So trioxide, dioxide, monoxide. Now you can use those prefixes for a whole lot of other chemical species, we'll call them. And that's just another way of giving something a name, which allows us to write down a formula, which allows us to get some idea of how many atoms there are together in that molecule.